Hi, everybody. It is just now 11 o'clock Central Time. I'm going to give folks 1 or 2 more minutes to get in, and then we will get started. All right, well, I show 2 after the hour, and I'm guessing we've got everyone here that's going to join us live. So thanks to those who are here with us today live as I go through this. And to those watching this as a recording, I thank you for watching this. I think you'll find it quite useful, not only for navigating the course, but with what we're covering in Unit 1. So with that, let me go through the slides. Here's what we're going to cover today. So you're meeting me. We're going to talk about expectations. We're going to tour our class. Within that tour, I'll also introduce week 1. We're going to talk about recommended resources that I have to help you be successful in the class. We're going to talk about the final exam as well, which might seem a little crazy this early in the course, but I think it'll make much more sense when we go through it as to why I'm talking about it now. I'm going to remind you of the late work policy that's posted in a course announcements. And then I've got a worked problem which ties directly to what you're covering in the Unit 1 assignment. And then at the end, I'll stick around for questions, but if you have them as I go, feel free to type them in the chat or just jump in and ask a question if you have it. So here I am, Dr. Liz Brown. I've been teaching here for several years. I've been teaching college chemistry, though, for over 20. I live outside of Chicago. I'm a huge Cubs fan, as you can see from my picture here. I don't have any kids, but those are my nieces who I adore. And this is me in the lower left there in my lab doing a demonstration. You can reach me through my email address, elizabeth.brown@columbiasouthern.edu, and then my cell phone number is there if you wish to text me something. I will warn you, I don't teach via text. It's way too hard to be typing out, long answers to questions on, on my phone. So send me a text if you have sent an email. If you need something more than just something simple I can answer via text, I'm glad to. But again, to explain something, I would ask that you keep it to email. If you want to send me a text that asks that I check my email, you've sent something, maybe it's time sensitive, you can do that. You're welcome to that. I'm typically online each morning. We don't have a requirement of exactly when we have to be online each day. Just like with you as a student, you probably enjoy the flexibility of an online class. I enjoy it as well as the instructor. So I'm on a minimum of 5 days a week. Those days may vary. Some days I take 1 day on the weekend off. But with that, again, typically I'm grading things you're going to see in a minute quite quickly in emails, 24 to 48 hours, you should have a response. So if you've sent something and I haven't replied, that's a good time to shoot me a text or check your sent folder and make sure it actually went. I'm sure you've all had experiences where you think you sent an email and then you find out it never went through. So what you can expect from me, as I said, I'm pretty quick with grading, all but the discussion boards. And that's because our discussion boards, our weeks start on Wednesday and they run through Tuesday. And then the next Wednesday, so the first day of the next unit, I will sit down and grade all of them at the same time, the discussion boards. But the homework, the labs, quizzes, things that you submit during the week, I will grade same day, next day as they come in. I don't hold those till the end of the week. So just keep that in mind. If you submitted something and you don't see a grade, check. I've had several students over the years that thought they hit, submit and sent it through on the Dropbox, but then didn't. So, check that out and see if it's still open for you to submit. That means you didn't actually send it through. So, and if it looks like it's there and I didn't grade it for some reason, again, shoot me a text, send me an email, and I'll check that out. But that's usually the first place I go when I log in our classes. I check out what do I have waiting for me to grade. So, and then also you can expect me, to be your biggest cheerleader. I am here. I want you to be successful in the class. And so just keep that in mind. What expectations do I have for you? Well, you're responsible for all communications in the course, announcements, information and study guides, even these webinars have important information. So if you can't attend live, be sure you're watching the recordings. The whole thing, they're always recorded, the entire webinar, and then it can take an hour or two for the system to process it after we wrap up, because it's usually around 45 minutes in length. But the same day, if not the next morning, you'll see I post a link in the announcements to the recording. If you're here live, you want to go back and watch it again, you missed something, I talk too fast, which happens sometimes, feel free, it's there. I expect you to give 100%. Obviously, you're in college chemistry, whether it's a face-to-face class or an online class. It's one of those topics that students almost always say it's one of their most challenging courses. So you're not alone in that feeling. It's just the content. Same thing for calculus most often. I know when I took Calc 1, 2, and 3, each time I thought I was going to not survive it. But that just meant I had to put a lot more time into it. It was a more challenging class. It doesn't mean it's impossible. It's just that you need to use your resources. You need to keep up with the work, ask questions when you have it. And those are kind of my next couple of points here anyway. So just keep in mind that as compared to some of your other classes, this is definitely going to require more work, more time, more of your time. Some students can do a problem or two and be great at anything else. And some students have to do 10 or 12 problems before, they understand the topic. So again, you can't compare yourself to others. Just work through and do what you need to understand the situation. Jonas, did you have a question? Oh, no, he lowered his hand. Okay. Again, don't get behind. We're going to talk about my late work policy, and I do work with you and accept almost all things late, but just keep in mind this is an 8-unit or 8-week course, and putting things off, unfortunately, just means it piles up at the end. So just keep that in mind. Talk to me if you need extensions, if you're struggling, and then also, and of course, in all classes, please be kind and courteous to everyone. Whether it's in a discussion board with a classmate on a topic you may disagree with them on, that's perfectly fine. You can disagree with them in a respectful way. And I know the online medium, whether it's an email or a discussion board, can be rather flat. You don't see people's facial expressions, their tone. And so, things are taken much more to heart. So please watch your words and how you, speak to each other, how you speak to me. It's appreciated. Okay, so with that, let's jump over and look at our class, and you're going to have to bear with me for a minute. The system is a little clunky when it comes to doing these things. Okay, so, all right. It says it's showing our course now. So let's take a look at our course. Let me change it to the mode so that it looks like what you see. So we're going to start just, let's go to the course home where the announcements are. Let's look through and talk about the announcements. There are a lot of them this first week, and these things will stay up all semester, but there's a lot to read through this first week. As with any new course, when you first jump in, you've got to get the lay of the land. You've got to, read a lot of information, read the syllabus, read the announcements, and then do the work for Unit 1. So again, try to do a little bit each day. so that you're not overwhelmed at the end of the unit or the end of the week trying to do everything at once. So I'm going to start from the bottom up here on the announcements. Some of these have been posted just by the college or by the university, excuse me, and I'm sure you've seen them in other courses. The Success Center, I'm going to talk more about them in a little bit. There's two ways in which you can contact them. One is through this announcement. The Math Center, of all these options, the Math Center is the one that applies most to our class. You're going to be doing a lot of math, not really any writing. So if you need to request help from the Math Center, you can go to this announcement and click Math Center Request. That's one way. You can see their hours and things as well. We're going to talk more about that in a minute, though. How to locate professor feedback. So this is a video the university created as to how you can review the feedback that I provide you on your assignments. So again, I assume you've taken other courses and you probably know that when I grade an assignment, you will get an email that says your grade and a basic breakdown. But you have to come back into the class, back into that assignment, open it up and review my comments that I've placed, whether it's with the quiz question or whether it's an assignment that I have put annotations on right next to the question or answer that you have given a wrong answer for. So come back in and please review that. All right, academic integrity. Again, this is also a university announcement, and it's just really important to note that the university feels very strongly, as do I, about your academic integrity. It can be a problem in this class. I'm just going to be really honest. Students have a tendency, I think, when they hit challenging problems, whether it's this class or any class, to Google questions and pull answers from things that are already out there. Two things I'll warn you about with doing that. One, many wrong answers are out there. And in fact, there's some really common wrong answers, and that's often the red flag for me that a student is copying. Work must be your own. If you can't solve the problem, ask me for more resources, ask me for more examples. They're in the book, they're in the study guides, there's videos, they're out there, but if you've somehow missed them, before you just copy another answer, take somebody else's work, especially because there's a high chance it's wrong, please contact me. If you are found to be copying even one answer to one question in the course, I will submit an academic integrity violation alert to the university, and they will investigate. And if you're found guilty, depending on the number of infractions you've had previously, the penalties can range anywhere from a minimum of is a 0 on the assignment, no chance to redo it. You're placed into an academic integrity course you have to complete, all the way through. I've seen students suspended from the school. So again, we take it very seriously, and I hope you do as well. All right, there's me. That was last summer over in Belgium. Just the welcome message. I'm guessing you've already seen this. If you are watching the video or you're here live, you've probably seen most of these announcements. My contact information is here again with the rundown of the, how to start, expectations, things like that. Study guides. Each of the units that we cover has a study guide, and I'm going to show you the one for Unit 1 today. The information in the study guide is very, very important. Now, that being said, it's not a replacement or a substitution for watching the lecture videos and reading the textbook. I had a student a year or so ago who we were talking one day, and he said, in my other class, I could just use the study guide, and the study guide had everything I needed to know, and I never had to open the book, I never had to watch a video, do anything else, and I was successful in the class. Unless you've had general chemistry before and done well, that's probably not the case in here. The study guide is essentially just an overview of the key points of the chapter. And again, because the material is so difficult, you really need to be watching the lecture videos, which I'm going to show you in a minute, and reading the chapter, working sample problems. So use the study guide as a resource. It is not your only resource to be successful in the class. I did create the curriculum for this course. I also wrote the study guide, so they go hand in hand. Okay, videos. So my little Breaking Bad guy here. I've created some videos for other classes. I've taught this general chemistry. Again, I've been teaching for more than 20 years, so I've taught it for over 20 years. And I've made some videos for the topics. I know that often with classes at CSU, you don't have lecture videos. We don't usually make them, but since I had them already, I thought I would provide them as, again, a resource. And so you can see here the list of Dr. Liz lectures that apply to the topics we're going to cover. It's kind of some of it's a little more of an overview than others, but just remember this is not from CSU. Disregard any mentions of due dates, any dates in general, assignments, things like that. I also have these broken down by topic and placed within the individual unit so that you don't have to go, which one should I be watching this week? I'll show you where they are within the units, but they're also here if you want to come back. The webinars, such as this one, I've saved and put a few of them on YouTube, so in case you want to work ahead, excuse me, let's say you want to work ahead and you're getting close to the final. Before you take the final, please, please, please watch the Unit 8 webinar. I work some sample problems that are just like ones on the final exam. And so again, in case you're working it early, before I've done the Unit 8 webinar, which I'll do at the start of Unit 8, but it's here in advance if you want to watch any of them. And again, keeping in mind, these are from other terms. I will place a separate announcement with the webinar for our specific section once it processes. All right, what else do I have here? Discussion boards. So every unit has a discussion board, and there are questions or question. This unit, there's two different parts, things you have to answer and discuss. But keeping in mind your main post, basically just two requirements for that main post. One is that it's done by Saturday night of each week. That's the due date for all discussion board main posts that the university sets. So 25 out of the 100 points is towards being on time with your discussion board post. Why is that so important? Well, you're in a course, you're in basically, we call it asynchronous, but it's really, I think of it more synchronous in that you've got 1 week to do the work for that week. We're on discussion boards with each other. So it's an active discussion board where discussions should take place between your classmates. If everybody were to wait until Tuesday, the day it's due, and just throw up their main posts, it would be very challenging for those that maybe did it early to even be able to have a discussion. And it really doesn't make a discussion very meaningful when it happens the last couple of hours before it's due. So that's why the university has that Saturday night deadline. And that's why I place such high point value to it. So 25 out of the 100 points is for being on time Saturday night with your main post. What's the other thing? Well, the other part in terms of points towards your main post is making a substantial one. So substantial is not, I'm not allowed to really give word minimums, but I can highlight this paragraph here. It's a couple of sentences. I can just look at that paragraph and know there's no way that's a substantial post if it just has a few sentences. Okay, and you can see some people have acceptable posts here as examples. Here are some unacceptable ones, and it's not always even just about the length. I can yammer on about nothing for an hour, but there's no substance there. So it needs to be substantial. Answer the question. Go into great detail. You may have to do a little bit of research even to answer the question or questions. But again, check out your classmates. I always have students posting great, great substantial posts, and you could just visually look at them and tell this one's probably going to get 100% on their point value for the main post because it's very substantial. So I pulled this from an online resource, remembering the acronym IDEA when you're writing a post. Identify, interpret, infer the principle that's being learned, define and dissect it, explore and explain it, and then analyze, apply, and advocate. We don't necessarily advocate for positions in this class, but you can analyze and apply absolutely. So be making the main post with substance. So out of the 100 points for the discussion, 25 is for it being on time, which is again by Saturday night of each week. And then 50 out of the 100 is for that substantial main post. What's the last 25? If you were doing the math, there's 25 points remaining, and that is, again, it's a discussion. It's not a journal. If you've taken any life-paced courses, you've done journals. Journal is just you answer the same question. They actually have a minimum word count, but it's life-paced, so it's, you post it during the course whenever you want. There's no back and forth discussions with your classmates. You can't even see your classmates' posts. But in here, this is a term course, and you do discuss with your classmates, which means the remaining 25 points is provided that you make a reply to at least one of your classmates, or to me, just doesn't matter, either one, within the academic week. So that's the point breakdown for discussion boards. All right, late work policy. As it says here, I'm glad to work with students who need assistance. I realize almost all, if not all of you, are working full-time jobs, have families, are taking other classes. Some of you are deployed military members. I thank you for that. I'm glad to work with you. Most important thing I should say regarding late work, though, in that situation is communication. You have to communicate with me. You have my cell, you have my email. It doesn't take 30 seconds to do one of those two things. And I say, you know, you signed up for a course. While I'll work with you and give you some extensions on things, you're responsible at the very least for using that 30 seconds and communicating with me that you need more time. You know, tell me what's going on, and I'm glad to work with you. So it can be via email or text. You have to make it before the end of the academic week. So don't get into Unit 6 and say, hey, I'm here now. I've been really busy. I'm sorry. Can I do all the work that I've missed? Again, that's what a life pace course is for, and we have sections of that running. They're great for students who just need a lot more flexibility with their timing. If you can't take one of those, or you just choose not to, keep in mind you're in a term course where we have weeks. Each unit runs a week. And then the other thing, as we talked about a little bit ago, discussion boards and their purpose in this class is to discuss and have active discussions with your classmates, with me. So your discussion boards are not accepted late because you've missed that. So again, if you do nothing else, jump in the discussion board, answer the question, reply to someone, and then shoot me an email or text message saying, hey, I need some more time on the rest of the work. Okay, here's the announcement for this today, right now, the webinar. And if you want to put this in your calendar, the webinars, there will be 2 more, Unit 4 and Unit 8. We'll do additional webinars. You'll notice the times are kind of all over the place. I do that on purpose. I try to hit everyone, whether it's a student who works during the day and can only do evening, or someone maybe who works second shift and I have an early morning, and then this one's kind of a midday for people doing maybe lunch break. So that's why the times are scattered as they are, to give everyone an opportunity. So please mark your calendar for the others, and if you can join, that would be great. Otherwise, as I've said a couple of times, it will be posted as a link, and you can watch it as a recording later. All right, so what else do we have? Again, the course is set up and laid out like your others, so I don't need to walk you through probably all of this. Here's an older video of me, but it's the same course. And then the transcript for it is here if you just like to read that. You can go through the e-textbook is here, the syllabus, but I want to show you Unit 1. So as I said, every unit is laid out very similar to whether it's our class or other classes. It starts with an introduction to the unit. So here's my introduction. And then I said a few minutes ago also that I include the lectures. I had that whole list of them in the course announcements. I break them down by the topics relevant to the particular unit in each introduction. So I have 3 of them here. We're covering a couple of chapters, so it's a lot of material in this first unit. And so those are the 3 lecture videos I recommend you watch. I detail the graded work, although it's also listed below this. Recommended resources, we're going to talk about study guide in a minute, grades, and then again, a reminder how to reach me. And then I always have some either inspirational quote, or this is informational instead of inspirational, information about we're breathing mainly nitrogen. 78% of the air we're breathing is nitrogen. Most think it's oxygen, actually. Attendance verification, this is just in Unit 1. CSU will verify your participation of academically related activities at the end of the first week. This is not something I do. It's done by the system, by Blackboard, and sent to CSU. Students who haven't done something academically, made a discussion board post, completed the assignment, they're withdrawn. I can't override that. You have to do something in week 1 or you will be dropped from the course. All right, study guide. I'm going to click on this and let's see, you guys should be able to see this now. Okay, so here's the study guide. Again, each unit has a study guide. The beginning, your learning outcomes, broken down by chapters and pages and all that. What chapters were chapters. Some units it's just 1 chapter, some it's 2. In this first unit, it's the first 2 chapters that we're covering. And then again, here's the lesson, which is an overview of the important concepts for the course. And while I'm scrolling through this, I'm going to say it one more time. You cannot just read this in the study guide and understand the material or be able to be successful. This is really just essentially a chapter summary that's got a lot more detail than the couple of paragraphs in total at the end of each chapter in the textbook. Some examples broken down here as well. Then we go into chapter 2. Again, some examples here. And I'll give you a hint. This example right here for chapter 2, this will be really important for your unit 1 lab that I'm going to show you in a minute, where it breaks down subatomic particles, all of this here in the middle. Okay, and then as we scroll to the end, there's some additional resources. I have some videos. Some are my videos that are different than the ones on the course homepage. This is one that's my previous name. Sig Figs, Calculations and Scientific Notation. If you need a refresher on that, you can watch this video that I made on how to apply that appropriately. And then Professor Heath's chemistry channel. This first video is on unit conversions. Another one that's on density conversions. There's always a transcript underneath. So it looks like there's a lot of links, but really it's a video and a transcript and a video and a transcript and so on and so forth. And then Chem Guy. Chem Guy also has some great lecture videos. He's standing in front of a whiteboard, working a problem, explaining it, and it's relatively short. I don't think I've ever seen one that's over 10 minutes, in fact. So you can watch all of these. There's 2 different ones. Right now I can't for the life of me remember which one, what he's covering, but take a look at those. I don't remember which ones I've pulled for this course, I should say, or for this unit, excuse me. And then non-graded learning activities, practice problems. Please work these before you do the assignment. There's also a video on how to do that. I've got to view the handout for additional help. And then finally, end of chapter problems, problems found within the chapter, just problems, and more problems. It's very math heavy, this course is, and I don't know about you, but the only way I really learned math was to do problems, regardless of whether it was calculus or algebra or trigonometry. I had to work problems until I got it, until the light in my head went off. Okay, so let's go back to our course. Okay, discussion board. Let me open this up. Some of you have already posted. Good for you. I've got to get in there today and start making some replies. So you will always see the first part, which is the question, or again, in this case, there's two parts. 1, introduce yourself. Share as much as you feel comfortable sharing with us. It's really nice to get to know everybody, know what their majors are, where they live, what they do for employment. But if you're not comfortable sharing that, just share something. I don't know, your favorite color, your favorite TV shows, so we can get to know you a little better. Then the second part, and this is what relates to our course, and that is find an example of matter near you. So I'm going to, for instance, I have a piece of paper sitting right here on my desk, probably hear it in my hand. I'm going to pick that as my example, paper. Just to detail its physical state. Well, it's a solid. That's its physical state. Is it a pure substance or a mixture? Well, this is where you may have to start doing some research. Go review what a pure substance is, what a mixture is, and then once you know that, if you're unsure what your substance that you select is, you may have to go look it up. For instance, what is in paper? Well, I'll tell you on my paper example, even if I don't know what paper contains, this piece of paper has ink on it, which means I know it's a mixture. And I would say that it's a mixture because it's paper and ink. If you want to take it a step further and read what composes ink, what composes paper, you can do that too. Discuss one physical and one chemical property of that substance as well you selected. So again, probably it's going to need a little review, whether it's of what physical and chemical properties are and or how that applies to your substance. You can see this graphic here. The chemical and physical changes are changes that occur to the substance. Some change the identity, that would be chemical. Some don't change the identity, but change the form. For instance, you can see shredding. So if I were to shred this piece of paper, that would be a physical change. Now, the question, however, asked for a property. How are changes in properties related? Well, properties simply describe a change. So for instance, I could say, if I cut up a piece of paper, that's a physical property, physical change. It's still paper, it's just physically changing the shape from one flat sheet of paper to a bunch of little tiny pieces of paper. That would be physical. Chemical, I'm going to come over here, probably the best example, combustion. If I were to burn this piece of paper, because paper is combustible, It would definitely burn. It would change from paper into something else. Even if you don't know what the something else is, that's okay. It's carbon dioxide and water in this instance. But the chemical property would be to say that paper is combustible. It will burn and it will produce new substances. Okay, so that is the discussion board. And so you're going to make your main post and then you're going to reply to at least one others. Again, keeping in mind, make sure your main post is substantial, answers all of the assigned questions, and is on time. Okay, and you can kind of scroll through and see lots of people have already started. And again, main post substantial. I'm just going to pick on Jason. Jason, this looks great. I haven't even read it, but I can tell you, it's got a lot of detail to it. So this, I would say, is probably going to be a great example of a substantial post just by flipping through quickly. Not to say the others are bad, just using that as my best example right now for what's on the discussion board. Okay, now let's talk about every couple of units, you've got a homework like this where you're going to be given problems, and what you're supposed to do after you review the handout and read and do the lesson, what you're going to do is you're going to copy and paste that to a Word document. As it says here, answers have to be a single Word document. Don't worry about citations and references. These are just word problems. They've got to be your own answers. Or again, we talked about academic integrity a little bit ago. So we're not writing an essay. You don't really have to cite and reference APA guidelines. It says at the minimum you can cite this textbook for question 3. That's fine. But again, it needs to be in a Word document. And I'm going to show you in a minute how you can type out word problems in a Word document. So copy paste this. There's 3 questions, but the first question has 5 parts, and each part is essentially a problem in itself. And we're going to look at one of these in the sample problems I'm about to get to in just a minute here. But key kind of takeaways where students tend to lose points, especially in this first one. As it says here, you have to show all of your work step by step to calculate the density of each, and it has to be in the units of grams per milliliter. Again, please stay on this, keep watching this. If you're watching it as a recording until I do the sample problem, you'll see what type of detail, what level of detail step-by-step work is. Second question, again, is a mathematical problem, and it's potassium has 2 naturally occurring isotopes. Here's the information. Calculate the average atomic mass. That's what's on the periodic table, but you've got to mathematically show and prove it using the equation from the chapter. And then finally, question 3, this is probably the easiest for everybody. It's essentially 2 parts. 1, name the steps of the scientific method, and then 2, apply that to an everyday problem you might solve using the method. So again, I'm going to give you an example for those that are watching this, and you can use this example. My car won't start. So the scientific method typically starts with a question or problem that needs to be addressed. So I go out to start my car won't start. Clearly, that's an issue. That's a problem I'm going to have to solve. So that's how I would start. My question or problem is that. Step 2, I'm going to hypothesize that my car won't start because the battery's dead, right? I made it home, so I probably have gas. Okay, I'm going to say the battery. That's my hypothesis, that the battery is dead. Next, I'm going to do some experiments to determine if that's true. My first experiment would probably be to try to jump start the car. That's my experiment. Based on the results of the experiment, I either then have to go back to the beginning and try again with a different hypothesis. So for instance, let's say I try to jump start my car and it still doesn't work. Well, there's several other things that could be wrong. So you now go next on the list. Maybe I am out of gas. Go get some gas. Try that. Work your way all the way down to the conclusion when you solve the problem, answer the question, figure out what's wrong with your car. Okay, so that's an example. And again, you can use that if you want to use it. All right, and then the last part of the assignments for the week is a lab. And we're going to be doing several labs. And I will tell you, this tends to be in Unit 8, when students are reflecting on the course, this tends to be their favorite thing, and that was the labs. It's an online simulator, and it's not even that you're going to be necessarily clicking on beakers and doing reactions, but more it simulates things at the molecular and atomic level, trying to reinforce the concepts learned. So the Unit 1 lab, there's always 2 links. One is to the simulation itself online, and one is to the worksheet, which also has a link and talks about the instructions. So you need to do both. And then when you're ready, just like with the homework, I forgot to tell you, but you click this big blue submit the assignment here. One file. You're completing this worksheet, saving the worksheet, and it goes all together. One document. Now, I can't, if I click and open this, it won't show it to you. So at this point, we're going to go back to we're going to come back in here, and I have the worksheet saved as a PDF, so I can actually show it to you. And I want to show you a couple of, again, common mistakes students make. I want to clarify things, even though it's here in the instructions. So when you go to the simulation online, there's a couple on the main home screen for this particular simulation. You can do one of several things. The first is build an atom. So you're going to click on build an atom, and then you're going to follow these instructions. Now, the instructions tell you to create an oxygen atom with 8 protons, 8 neutrons, 8 electrons. Follow the directions below and observe what happens and complete this table. So again, you're going to be working in your Word document. When you're ready to answer a question, click your cursor, type the answer in each line. So first thing you're going to do is you're going to have 8, 8, and 8, and you're going to increase the neutrons from 8 to 9. And then you're going to identify how, if any, the charge of the atom changes. You're going to identify, if anything, how the mass of that atom changes, how the atomic number changes, and type of atom is simply, is it still oxygen or is it some other element now? So again, here's where students go wrong. They just give me the new value. That's not what the question says. The question says, how does it change, if any? So you would say it doesn't change at all, it increases by 1, it decreases by 1, or it stays the same as oxygen, for instance. Okay, so again, follow that. That's really, really important. A lot of students just put the new value. They're not answering the actual question, which is addressing how much it changes. Okay. All right, so you do that. Then you reset it back to the original, 8, 8, and 8, and do the second one. Go back to the original, add an electron. So you'll have 8 protons, 8 neutrons, and 9 electrons. And then talk about how the charge, the mass, the atomic number, and if the type of atom changes. You'll be able to see all that in the simulation. Okay, now the next thing you're going to do, and my apologies because the instructions start on the bottom of page 1 and then it goes over to page 2. So using your periodic table, pick 3 elements up to neon. Don't go anything beyond neon, or they're just too big and cumbersome. So, keep it simple, keep it smaller atoms. Build their atoms using the simulator. Each atom, however, must be stable and neutral. There's actually a box that you can click for it to show you if the atom is stable or unstable. Click that box so that you know. And then fill in the information as you build each atom. And here's the information on page 2. I'm going to blow this up. So for the first element, let's say again you pick oxygen. You can do oxygen again. 8 protons, 8 neutrons, 8 electrons if you choose, or you can pick, you can vary the numbers this time as you choose, as long as it's neutral and stable. Neutral means equal protons and electrons. And then you have to take a screenshot of that atom you built. You can either do that if you know how to do it with your own individual computer, or there's a take a screenshot option is in the simulator. You can do either one, but you've got to then place the screenshot right here. So you'd put your cursor here underneath screenshot of completed atom, click it and hit insert, insert that file. It has to be with the element in question, or I don't know what which one goes with which, and I won't accept it. You won't get credit for that. Then you also have to say what's the atomic number and what's the atomic mass for the isotope you created. Don't go to the periodic table because it may not match. Depends on the isotope you designed. Okay? So you do that for 3 different elements. All right, the next thing you're going to do, you're going to do atoms, ions, and isotopes. Oh my. And this part you can probably do without even using the simulator. Of the 3 subatomic particles, protons, neutrons, and electrons, each one is going to go on one of these lines. Give you that hint. So which one affects the charge? If I add or take away this one particular subatomic particle, which is what we do so often, or even nature does so often, which one will give the atom a charge, making it an ion? Which one changes the type of element your atom is? So back up to part 1. When did it change from an oxygen to fluorine? What did you do? Which particle changes what you have? And then finally, which one makes it unstable? So again, your hint is protons, neutrons, electrons. Each one is going to go on one of these lines. You're not using any one twice. Atomic number, atomic mass, and charge. Same thing here. Each one of these is going to go on one of these 3 lines. So this is the symbol for lithium, 7, 3, and 0. What are the numbers? Which one is atomic number, which one is atomic mass, and which one is the charge? Put your cursor on the line, type in the answer. And then you're going to design two more particles. These are going to be ions. The first one is a stable. So remember, check that box for stable and unstable so that you know. It needs to be a stable fluorine ion with a charge of 2+. Then you need to take a screenshot and put it in this box here. Then do the same thing for carbon, but you're going to have a stable carbon ion with a charge of -1. Take a screenshot, put it there. And then one last thing, you're going to go all the way back to the beginning of the simulator and you're going to click the games. It's the third option. You're going to play the games. There are 4 games to play. When you're done, go back and get the summary of your scores. Essentially, it's going to look like this. You take a screenshot of this with how many stars you've got filled in. The stars will turn yellow. You need to get at least 1. That shows me you attempted it. You don't have to get all 5 stars, although that would be great if you're an overachiever and you want to get all 5. So play the 4 games, take a screenshot of the results, and just click your cursor underneath this sample and insert your results. Save this as one PDF, or excuse me, well, it can be a PDF if you want, but save it as either a Word document or a PDF. You're going to upload 1 file back in the class. Okay. Sorry, I'm taking a little longer than I meant to, and I'm back to the presentation, and it makes me go back to the beginning. Let me go back to where we were. All right, so we toured our class. Recommended resources. I've kind of talked about these as we've gone, those presentations, the videos, the study guides, using the Math Center. The Math Center is a fabulous, fabulous resource. Even if you're not struggling in the class, if you want to see what resources they've developed for our class, fill out the form. Click on that link. It's either on the left-hand side of our course in the menu, or it was that announcement at the very bottom that I showed you of the Success Center, and you click on the Math Center. Chem Guy, I've got several of his videos, individual videos within the study guides, but this is the website, the link for his whole list of problems. And he's got them all broken down by topic for Gen Chem 1 and Gen Chem 2. And they're great videos. And then, of course, there's lots and lots of YouTube channels out there. These are some that students have given me over the years that they like. There's far more than this. Crash Course Chemistry is probably my favorite. I think he's kind of funny too. But you know, use your resources. Ask me for questions. Watch videos. And then finally, college level chemistry textbooks, and well, let's just be honest, chemistry textbooks in general, I know are not the most exciting things to read. But let's say you read about density in our class, or you know, in our book, and it's just not clicking, it's not making sense. You need to read about it another way or see it another way. And you've watched my video and said, it's still not clicking. Here is another textbook that you have access to. It's actually an open resource, open educational resource text. It's free. So if you want to use this book, you can. We're not allowed to use it for the college, the university. I have no idea why. It's used commonly. The book we actually use is the #1 used general chemistry book in college, but this free OpenStax textbook is also becoming more and more commonplace. So you feel free to use that as well to read the chapters. Just note the chapters don't necessarily correlate in order of ours. You'd have to figure out what the concept is being covered in our class and then go find that in that textbook. But there's more sample problems, there's more problems you can work, and again, topics just explained a little differently. Maybe that would help you. Okay, I said I was going to talk about the final exam. Seems kind of crazy now, but this is the reason. The final exam, like all courses, is proctored. You either have to be on the computer using the remote proctor service, which is an on-demand, so you can do it any time of day, as long as your computer meets the requirements. You have to have a laptop or a desktop. Can't use Chromebook, can't use tablets, you can't use your smartphone. And it also has to have a webcam, a mic, and stable internet. If you don't have that or choose not to use the remote proctor, you can use a human proctor, but it has to be someone neutral, like a librarian. It can't be a family member, and you have to fill out a form. And it takes time for the university to process those forms and approve your proctor. So the reason I'm bringing this up in week 1 is if you are going to use a human proctor, now's the time to make the decision in the first couple of weeks, because you need to fill out the form and you need time for the university to review and either approve or deny. If you get denied, you got to come up with plan B. So that's why I mention this now. There's actually a whole thing about it in Unit 2, because the university is trying to, light the fire under you to make a decision. So start thinking about it this week. And then I would say in Unit 2, try to make your decision. Determine if maybe your system meets the requirements or not. There's a link. Those are listed as well in Unit 2. If your computer doesn't meet the requirements, you can go to a friend's, but you again have to be in a quiet room, without anybody else around. So kind of start thinking about that now. All right, I already talked about the homework and late policy. So I'm going to leave you with working a sample problem. This is very similar to the question 1 problem that dealt with density. You have to do this 5 times though in question 1. So let's kind of work through some problems here. I'll show you how I work word problems. Get my pencil ready. A 10,000 kilogram sample of water occupies a volume of 10 kiloliters. What is the density of the water in the units grams per milliliter? Okay, so there's several ways you can start this off. First is recognize what do you need to be able to solve for density. I need mass and I need volume. Second thing, identify what the problem gives you. The problem gives me 2 numbers in units. 10,000 kilograms, that's a mass. I'll label that M. 10 kiloliters, liters is the base unit for volume, so there's my volume. Now, before we just jump and plug and chug and be done, here's where it can get challenging, and that is the requirement that the answer be in the units grams for mass and milliliters for volume. So neither one of these is in the appropriate unit that's needed to be able to just plug and solve. And I really recommend you convert them before you plug them in. It just gets a lot more complicated. So it doesn't matter which one you want to do first. I'm going to go ahead and do mass first. So I have 10,000 kilograms. And I don't want kilograms. I want grams. Okay, so I'm going to set this up. I'm going to try and do this nice. It's kind of hard with the computer, but so I'm given 10,000 kilograms. I don't want kilograms. I want my answer for mass to be in grams. So I'm going to put kilograms on bottom. And give me a second and I'll talk about the numbers. And I'm going to put grams on top. I knew that because I wanted to cancel kilograms. So I put whatever you don't want on bottom. I want grams. So I put that on top. Now, where did these numbers come from? 1 kilogram equals 1 gram. Well, it comes from the conversion factor, the metric. 1 kilo of anything is equal to 1,000 of the base unit. 1 kilogram equals 1,000 grams. 1 kiloliter equals 1,000 liters. 1 kilometer equals 1,000 meters. So that's, again, your metric prefixes. That's all. And you always keep the number with the unit. So wherever I had kilograms, which was on bottom, I put the 1. Wherever I had the unit gram, I put 1,000. And keep that together. Okay, now let me come back down here. Now I'm ready to do a little plugging and chugging. Whoops. No. Trying to get this to work a little better. Let's see. No, maybe not. Okay. So what do I do with my calculator? Well, you multiply anything that's on top. So 10,000 times 1,000. Then you divide by anything that's on bottom. And I have a 1 on bottom. So it's 10,000 times 1,000. And since I'm kind of limited on space, I write in scientific notation. If you aren't familiar with scientific notation, now's the time to refresh your memory from math class. Again, I also have that video in the study guide on that. Now, I can't do fancy formatting here. Typically, let me scribble it. What we would write is 1 times, I'm trying to do this with my mouse, so that's not really great, times 10 to the 7. Okay, that's how it would look normally. The caret just means it's going as a superscript. So 1 times 10 to the 7th. So that's my mass in the appropriate unit, grams. Now I've got to convert volume from 10 kiloliters into milliliters. So let me show you how I'm going to do this. Let me set it up and then I don't multitask always really well, so let me, okay. So you'll see I have two, these are called equalities or conversions that I'm going to do. I have two here because I'm not just going from kilo back to the base unit like I did for mass. I'm going to do that. I'm going to go kilo back to kiloliters back to the base of liters, but then I need to go to milliliters. This is another prefix. Now, if you can find and you know the conversion to go from kiloliter into milliliter, by all means, go for it. And it's out there somewhere. However, I don't know it off the top of my head even. I've been doing this a long time. I do, however, know the kiloliter to liter and then the liter to milliliter. So I don't mind doing it in two steps. And in fact, it gives me something to show you as well as far as just another kind of different problem where it's two steps. So look at this. We already said 1 kilo is equal to 1,000 of the base unit, right? So I need that again. And then 1 liter, 1 base unit equals 1,000 milli of whatever. So in other words, 1 liter equals 1,000 milliliters, 1 gram equals 1,000 milligrams, 1 meter equals 1,000 millimeters. It's the beauty of the metric system. That's why we like it so much. Okay, so now I'm going to come down here and I want to put kiloliter on bottom because I'm going to cancel that in the first step. I'm going to go from kiloliter, I said, into liters. So there's that first equality, 1 kiloliter equals 1,000. But I don't want an answer in liters, I want an answer in milliliters. So that's why I'm doing the second equality. There we go. Okay. And again, I did all that because I want kiloliters on top and bottom to cancel, liters on top and bottom to cancel, left with what I want, milliliters on top. So the next thing and final thing for this part at least is to do the math. Again, multiplying anything across the top, dividing anything on the bottom. So 10 times 1,000 times 1,000 divided by 1, and this just by chance happens to be the same. This one also, when I plug it in my calculator, is 1 times 10 to the positive 7th. Again, just by chance. You usually don't have the same answer. This is because it's water, and water has a density of 1. But that's still what we have to solve for. So now I have my mass in grams. I have my volume in milliliters. Now I'm going to come over here, if I can get my cursor. Density equals, I'll set up my fraction here. So mass goes on top, 1 times 10 to the 7th grams. And volume goes on bottom, just again happens by chance to me that they're one and the same. And when I do that math, move that up so it's a little prettier. Okay. When you divide by the same thing, you get an answer of 1. Don't forget your units. So the density of this particular substance in the unit grams per milliliter is 1. As I said, in your unit homework, you're going to have to do this for 5 substances. And some of the problems, they're already in grams and milliliters. So it's a plug and chug. 2 of them are like that, in fact. 3 of them, however, need some help. They need some converting, like I showed here, converting into the grams unit for mass and the milliliter unit for volume, and then you can plug and chug. But for those, again, you have to show your math, showing me what the new mass is in grams, the new volume is in milliliters. Without the work will get you no credit. Show your step-by-step work, and that applies to everything in the class. There'll be a quiz question in Unit 2 where you have to convert, I think it's liters into milliliters. And if you don't show how that converts, like I did here for kilograms to grams, if you don't show it, you lose points. So again, always, always show your work. So that is all I have, you guys. I'll leave this up in case I went a little too fast for anybody, and I'll stick around for a couple minutes in case there are questions. Thanks for attending. Thanks for enrolling in class. I'm looking forward to a great 8 weeks with you.